Manufacturers' hot tub installations may not always comply with the National Electrical Code. According to the NEC, hot tubs must meet certain requirements. Firstly, electrical service must have a dedicated circuit with a minimum ampacity of 50 amps. Secondly, a circuit breaker or fuse must be sized to protect the circuit at 125% of the load, which translates to 62.5 amps. Thirdly, a ground fault circuit interrupter must be installed on the line side of the circuit breaker or fuse. And fourthly, a local ground fault circuit interrupter must be installed on the lighting circuit. It sounds like a 50 amp ground fault circuit interrupter was installed, which meets the NEC requirement for the main circuit. However, there was no mention of installing a local ground fault circuit interrupter on the light circuit, which is a violation of the NEC. Non-compliance with the NEC can increase the risk of electrical accident. Electric shock is a significant hazard. A ground fault circuit interrupter is designed to trip quickly when a current imbalance is detected, preventing serious injury or death. Fire is another risk, as overloaded circuits can overheat and cause fires. Damage to equipment can also occur, as improper wiring or lack of proper protection can damage the hot tub or its components. It is recommended to have the installation inspected by a qualified electrician to ensure it meets all NEC requirements. Explain the importance of local ground fault circuit interrupters on the lighting circuit for added safety. If the installation is not up to code, it should be corrected immediately to prevent potential hazards. Electrical codes and standards are essential for ensuring safety and preventing accidents. Adhering to the NEC and other relevant regulations is crucial when installing electrical equipment, especially in potentially hazardous environments such as those around water. Ground fault circuit interrupters play a vital role in protecting individuals from electric shock. They are designed to detect even small imbalances in current and quickly shut off the power, preventing serious injury or death. The NEC specifies where ground fault circuit interrupters are required, and these requirements should be strictly followed. Dedicated circuits are also important for ensuring the safe operation of electrical equipment. By providing a separate circuit for a specific appliance or device, you can prevent overloading and reduce the risk of fire. The NEC provides guidelines for determining the appropriate size and type of circuit for various applications. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from damage caused by excessive current. They work by interrupting the flow of electricity when the current exceeds a certain level. The NEC specifies the appropriate size and type of overcurrent protection device for different circuits and applications. Electrical inspections are an important part of ensuring the safety of electrical installations. A qualified electrician can inspect your wiring and equipment to identify any potential hazards and ensure that they meet all applicable codes and standards. Regular electrical inspections can help prevent accidents and protect your home or business from fire and other electrical hazards. When working with electricity, it is always important to take precautions to protect yourself from electric shock. Wear appropriate personal protective equipment such as gloves and safety glasses. Work in a dry environment and never touch electrical components with wet hands. If you are not comfortable working with electricity, hire a qualified electrician to do the job. Proper grounding is essential for preventing electric shock and ensuring the safe operation of electrical equipment. Grounding provides a path for fault current to flow back to the source, which can trip a circuit breaker or fuse and de-energize the circuit. The NEC specifies the requirements for grounding electrical systems. Bonding is another important safety measure that helps to equalize the voltage between different metal parts of an electrical system. This can help prevent electric shock if a fault occurs. The NEC specifies the requirements for bonding electrical systems. Wiring methods refer to the types of cables and conductors used in electrical installations. The NEC specifies the acceptable wiring methods for different applications. It is important to use the correct wiring method for the specific application to ensure safety and prevent damage to the wiring. Electrical boxes are used to enclose and protect electrical connections. The NEC specifies the requirements for electrical boxes, including their size, type, and location. It is important to use the correct electrical box for the specific application to ensure safety and prevent damage to the wiring. Conduits are used to protect electrical wiring from physical damage. The NEC specifies the requirements for conduits, including their type, size, and installation. It is important to use the correct conduit for the specific application to ensure safety and prevent damage to the wiring. Electrical panels are used to distribute electricity to different circuits in a building. The NEC specifies the requirements for electrical panels, including their size, type, and location. It is important to use the correct electrical panel for the specific application to ensure safety and prevent overloading. Lighting fixtures are used to provide illumination. The NEC specifies the requirements for lighting fixtures, including their type, location, and installation. It is important to use the correct lighting fixture for the specific application to ensure safety and energy efficiency. Switches are used to control the flow of electricity to lighting fixtures and other devices. The NEC specifies the requirements for switches, including their type, location, and installation. It is important to use the correct switch for the specific application to ensure safety and convenience. Receptacles are used to provide a convenient way to plug in electrical devices. The NEC specifies the requirements for receptacles, including their type, location, and installation. It is important to use the correct receptacle for the specific application to ensure safety and convenience. Appliances are electrical devices that are used to perform specific tasks. The NEC specifies the requirements for appliances, including their wiring, grounding, and overcurrent protection. It is important to follow the manufacturer's instructions when installing and using appliances to ensure safety and prevent damage. Motors are electrical devices that convert electrical energy into mechanical energy. The NEC specifies the requirements for motors, including their wiring, grounding, and overcurrent protection. It is important to follow the manufacturer's instructions when installing and using motors to ensure safety and prevent damage. Transformers are electrical devices that change the voltage of electricity. The NEC specifies the requirements for transformers, including their wiring, grounding, and overcurrent protection. It is important to follow the manufacturer's instructions when installing and using transformers to ensure safety and prevent damage. Generators are electrical devices that convert mechanical energy into electrical energy. The NEC specifies the requirements for generators, including their wiring, grounding, and overcurrent protection. It is important to follow the manufacturer's instructions when installing and using generators to ensure safety and prevent damage. Batteries are electrical devices that store electrical energy. The NEC specifies the requirements for batteries, including their wiring, grounding, and overcurrent protection. It is important to follow the manufacturer's instructions when installing and using batteries to ensure safety and prevent damage. Renewable energy systems, such as solar panels and wind turbines, are becoming increasingly popular. The NEC includes specific requirements for these systems to ensure their safe and reliable operation. It is important to consult with a qualified electrician when installing a renewable energy system to ensure that it meets all applicable codes and standards. Surge protection devices are used to protect electrical equipment from damage caused by voltage surges. The NEC specifies the requirements for surge protection devices, including their type, location, and installation. It is important to install surge protection devices to protect your valuable electrical equipment from damage. Arc fault circuit interrupters are used to protect electrical circuits from fires caused by arcing faults. The NEC specifies the requirements for arc fault circuit interrupters, including their type, location, and installation. It is important to install arc fault circuit interrupters to protect your home from fire. Electrical safety is a critical concern in all aspects of our lives. Understanding and adhering to the NEC and other relevant regulations is essential for preventing accidents and protecting ourselves and our property from electrical hazards. The NEC provides comprehensive guidelines for electrical installations, covering a wide range of topics, from wiring methods to grounding and bonding. It is important to consult with a qualified electrician when performing any electrical work to ensure that it is done safely and in compliance with the code. Staying informed about electrical safety is an ongoing process. The NEC is updated regularly to reflect changes in technology and best practices. It is important to stay up to date on the latest requirements to ensure that your electrical installations are safe and compliant. By taking the time to learn about electrical safety and following the NEC, you can help prevent accidents and protect yourself and your property from electrical hazards. Remember, electricity is a powerful force that should be treated with respect. Always exercise caution when working with electricity, and never hesitate to seek professional help when needed.